All right, number 5. We're just doing odd ones here. What's the cube root of 8? 2. 2 to the 4th is 16. What's the square root of 64? 8. 8 cubed is 512. The 4th root.
Things past 5.
You need to know up to 6. Yep. You good?
Yeah.
Okay. What's the 4th root of 625? 5. 5 cubed is 125. The 5th root of 32? 2. 2 cubed is 8. Are we good on those? So just know this test you will not use calculator for, okay? Alright. Let's look at the next part. It says rewrite each expression using the exponent. We're not evaluating, we're not coming out an answer, we're just going to rewrite it. How can I rewrite that using the exponent? That would be what? 6 to the 1/2. Because that is a square root, so that goes on bottom. What's the understood exponent with that 6 under it? A 1. So that's why it's 6 to the 1/2. Does that make sense? Okay. Number 15. How would I write that? X to the what? 3/4. Because the root is 4. That's in the denominator. And the 3 is going to be in the numerator. Alright. Number 17. 1 over x to the 6. I want to rewrite this using a negative exponent. Because when you do derivatives in Cal 1, you got to be able to rewrite it so you can rework it. So you can work with it. So how could I write that using a negative exponent? How would I get to this form? Only if I had a negative. I know this is a review. And I know some of you might be bored, but you got to pay attention to me. Okay. Now, how would you do it, Jack? That's correct. Because if I had that, that's how I would get rid of that negative exponent, wouldn't I? So if it's in the denominator, you're going to bring it to the numerator. If it's in the numerator, you're going to bring it to the denominator. Okay? Now, number 19, the way I would do this one, guys, I would simply keep the 1/3 like that and put x to the negative what? 1/2. Okay? Because that is in the denominator. I'm going to rewrite that square root as a exponent, so that's 1/2. This is the denominator. I'm putting negative 1/2, and just put that 1/3 out on the side as the coefficient. Does that make sense? Okay. We want to rewrite this using a negative exponent. Okay. This is the denominator. You're working backwards. How would I get it into that denominator? We're going to rewrite it, because if I had this negative 6 to get rid of that, I'll put a denominator, so I'm going backwards. Okay? It says write using an exponent. Well, I do not have an exponent, but I can make that square root into an exponent. Because the square root of x is the same thing as x to 1/2. And since it was in the denominator, I put x to negative 1/2. I just brought that 1/3, because if I multiply this, 1 times this, that would be x to the negative 1/2 over 3. And that's equivalent to that, because to get rid of that negative exponent, I would have brought it down to the denominator. Does that make sense?
I was just thinking x to the negative 2/3.
No. Okay. 2/3. Okay. If you said x to 2/3, what did you say, hon? What did you say you had? Okay. Negative 2/3. What you would have there would be 1 over. That's what you're saying right there. Does that make sense? Do you see the difference in the two? Are we sure, guys? Well, let's go and do these two, because I think that might clear up here. Like on this right here, I could just write that as 2/5. Do y'all see that? X to the what? Negative 2. Does that make sense? On this one, I would pull that fraction out, 1/2. That y is a cubed y in the denominator. So it'd be y to the what? Negative 1/3. Do y'all see that? Yes, Tyler?
This is just like a general question.
Mm-hmm.
So like on 18, instead of doing it like that, could you do put 5x squared in parentheses and just a
Okay, say again. What did you say?
So like just put like 5x squared in parentheses and then just raise that to the negative first. No, like 5x squared. Put 5 and then x squared and then raise to the negative 1. Which would end up being the same thing.
Which number? Which one are you saying this to? Number 18? No, that would not be the same thing, because what you would have is you would have that's equal to that, and you wanted a 2 over that, and what you give me is 1 over 5x squared, so that would not be the same thing. Yeah, see that? Are there any other questions?
Number 20. Why is it negative 1/3?
Okay, why? Because it's in the denominator. The radical is in the denominator, so that's why it's negative.
No, he's saying why is it?
Oh, no, wait. I see.
Oh,
Like, it's just because it looks
oh, you got it, Jack? How would I write number 14 using an exponent?
That would just be
8 to the what? 1/3, and this would be y to the what? 2/5. Are we good? We're going to keep practicing that, okay? You can put that away. All right. So let's talk about learning targets. First one we did, we have a quiz tomorrow on these 2 learning targets. Quiz tomorrow on this. It's 6 questions, okay? All right, so graphing the parent functions. Now tomorrow the first 2 is graphing the parent functions. And when you have the graphing tomorrow on the first 2, you can just do 1 cycle, okay? Because I just want to make sure that you know the general shape. Now I'm going to ask you questions about the parent functions, and we need to know them. What's your domain for both of those? All real numbers. Very good. What's your range?
Negative 1.
And what goes around them?
Brackets.
Very good. Are they continuous?
Yes.
Yes, they keep going and going, don't they? Why are these functions known as periodic functions? Because they continue to what? Cycle. Very good. They continue to cycle. Okay. Do they have end behavior? No. Why? Because they do what? Oscillate back and forth. It's like a spring is bouncing, okay? Where's your x-intercepts on this one? Pi n, for which n is an element of z. Here is what? Pi over 2n, which is n is an element of z. So, are we good on the parent functions? All right. Now, you have some homework, and I'm going to go turn that money into the office. I want you to be checking. This is number 1. Let me zoom out. I'm going to zoom out, and if you cannot see it, you can come up here and look at it. But this is 1 and 2, okay? 1 and 2. Be checking your work. Are there any questions on number 1 and 2? Yes, Miss Sue said we can just continue turning tuition this month, this week, and she's locking up in safe and going to give it to Miss Vickers to turn in when she gets back. Okay, we all good? All right.
So are they contacting Just State to extend the deadline or something?
Hold on. No. Okay, so we got to put a date on it. So it's like due. So we have to. Miss Vickers takes that tuition to Jeff State and delivers for you. So this week, just get it in this week, okay? All right, let's look at number 3 and 4. But if you want to pay with a card or pay on, you can just call Jeff State and pay through the card, whatever you want to do. But if you turn in a check or a money order, you bring it to us. All right, number 3, y equals 4 sine 1/2 theta. Your amplitude is 4. Your period is 2 pi divided by b. My b value is 1/2. So 2 pi divided by 1/2 be 4 pi. My y-axis is set by my amplitude, period. I take 4 pi divided by 4. I'm going to increase by pi. It is sine. I'm going to start at my origin, go up to my amp, and so forth. And there's your domain and range. Number 4. You got y equals -3 cosine theta. Amplitude is the absolute value of A. So your amplitude is 3. That refers to the height of the graph. Period. 2 pi divided by B. The B value is in front of theta. What's your B value here? 1. 2 pi divided by 1 is 2 pi. My amplitude is my y-axis is set by my amplitude. Period. I take my 2 pi, divide by 4. That's pi over 2. There's going to be 9 values, including the origin. Okay. Now, cosine, you start at your amp. But however, what does this negative sign do for the graph? It does what? Reflects. So instead of starting up here at the amp, it starts here. Does that make sense? And go from there. All right. And number 5. Y equals 1/2 cosine 4 theta. My amp is 1/2, not 1. My period is 2 pi divided by b. Well, my b value is 4. So my period is pi over 2. It takes a distance of pi over 2 to complete one cycle. Now watch this one. I'm going to take my period and divide it by 4. When I divide by 4, you end up flipping the fraction. Pi over 2 times 1/4. That gives you pi over 8. Does everybody understand that part? So that means I'm going to start with 1 pi over 8 and then add 1/8 to it. 1/8, 2/8, reduce, 3/8, 4/8, reduce, 5/8, 6/8, reduce, 7/8, 8/8, reduce. Okay? So if we graph 2 cycles, if one cycle is pi over 2, where should you end? Pi. And is that where we ended? Yes. Okay, so cosine, you start at your amp and then go like this. Are we good on those 5? Alright. Today, guys, let's turn to page 3. We're going to do 3 examples and go slow with those 3 examples. We're not starting off with number 1. That's the order. We're going to start with 2, 3, and 4. Alright. So let's look at our learning. Now, these type are not on your quiz tomorrow, just what we had, okay? Now, your learning target. Our learning target for the past couple of days is I can graph sine and cosine functions by using amplitude and period, which you're good at. Now we're going to add 2 more components to it, okay? We're going to add vertical shift, which is up and down, and phase shift. You said I've never heard of phase shift. That refers to horizontal shift. They just don't call it horizontal. That's phase. So phase shift is moving right or left, and vertical is up and down. Okay, those are the transformation rules we're dealing with, and the reflection. We don't stretch and shrink. Okay. Now, let's remember something. If it's inside the parentheses, that affects the what coordinates? X. So that's going to be your phase shift because you're moving right or left on the X. Okay. So inside the parentheses. Now, what do you remember about inside the parentheses? It's opposite of what you think. So if I see a negative pi over 2, I'm actually moving it right pi over 2. Do you see that? Now, if it's on the outside Okay, first off, that's the phase shift, but if it's on the outside, that deals with up and down, don't it? So that's called the vertical shift. Is everybody good? Alright, so, now I'm going to teach you, I teach you my way, the way I had to do it in college, because I have to work it out. Some of you will be able to see it in your mind and draw the final, and I'm good with that. But I'm doing the long way because that's what I had to do. Okay? And that's the way I'm going to expect. But if you prove to me you can do it in your head and draw the final graph, that's great. But I can't do that, okay? So here we go. Number 2. What is your amp there, guys? 2. Now you say when that becomes parentheses, guys, where does your B value fall? It falls outside that parentheses right there. What's understood right there? 1. So 2 pi divided by 1 is 2 pi. Because, guys, you want the value with that x, like inside that parentheses, to be 1, okay? So, you said, this just, what do you mean? You see, like in this example, there's a 2 in front of the x. Tomorrow, we're going to have to factor that 2 out and put it out here. So that's what I'm saying. You want that right here next to x to be a 1. Does everybody understand that? Okay. Phase shift. What's my phase shift?
No.
Would you put negative pi over 2 or pi over 2? Pi over 2. Opposite what you see. Do I have a vertical shift? No. I put not available, or that just sounds horrible. Just put a line, it doesn't exist. Alright. Now I have to do all these on graph paper. Because guys, what I do, well, no, I might have some room. We'll have some room right here. I'll do it on here. I draw a table. So, oh God. It's not too bad. How many points did we have on those graphs last night? 9. I draw 9 boxes. Alright, on the top line, I would put the points as if I only were graphing like I did last night, amplitude and period, okay? So what right now, that top is only going to be the amplitude and period. Okay, so in those graphs last night, we always started at x at 0, didn't we? Okay? Now, how do I find my x coordinates? I take my 2 pi and divide it by what?
4.
So that's going to be pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2. Are there any questions on how I came up with those yet? Those are just my x coordinates if I was just graphing. Now guys, if you don't have these two components in the graphs, do we have to do this long way? No, you do like what we've been doing, okay? The only time you have to draw a table is when you got one of these components or both of those components, okay? Now, we're going to do the y coordinate, so you got to think in your mind. This is what type of function? Sine. Do I start at my amp or do I start at the origin? Origin. So, I would have been 0, 0. Then I would have went up to what number? 2. Then went back to what? Then to 0, 2, 0, negative 2, 0. So that's how I will get my y coordinates. I'm just going to give you the statistics from last year. I only had 2 kids out of 25 to do this in the head. So most of you should be drawing the table right now. We're not be doing this in our head, okay? Now, phase shift deals with what coordinate, x or y? X. So I will take pi over 2 and add it to one of each of my x. What's 0 plus pi over 2? Pi over 2. Pi over 2 plus pi over 2 is pi, okay. 0 plus 1/2 is 1/2. 1/2 plus 1/2 is 1 whole, isn't it? 1 plus 1/2 would be 3 halves. 1 and 1/2 plus half would be 2. 2 plus 1/2 would be 5 halves. Do you start seeing a pattern emerge here? Okay. Do I have a vertical shift here? I didn't have a vertical shift, did I? So what would you do with your y coordinates? Just bring them straight what? Down. And then those are the points you graph. The bottom line is what you graph, okay? So, you see, Mr. I really could have done that in my head. They get a lot harder. And that will be my graph of that particular function. The reason I had to figure out the table was best for me in college is it was what coordinates to put on the x-axis. I just couldn't. I had to see it. Because, yeah, this is easy as half, but when we're doing like pi over 6 in a minute, or pi over 8, or pi over 12, it's a little bit more complicated. But it's the same procedure.
Why did you not start at 0?
Okay, because this is my new set of coordinates right here. Pi over 2, 0. So pi 2, 0. I plot that. That's your x coordinate. Pi over 2, y coordinate 0, so I start there. See, these were my original if I was only graphing that, but I got to transform the graph using this. So these are the ones I actually. What now?
When you still started the origin?
No, because that's not one of my points right here. My point is pi over 2, comma 0. Does that make sense? All right, number 3. What is my amp there? What's my amp?
Alright.
1, yep. Period. What's my period? 2 pi over b. What's my b? 1, so it's 2 pi. Yes, right now today, a bunch of your periods going to be 2 pi. They get a lot harder. We're doing an intro today. Do I have a phase shift? What's my phase shift? Pi. Opposite of what you see. What's your vertical shift? 2. So in this case, we're going to have a phase shift and a vertical shift. So I'm going to have to add something to my x and add something to my y. Okay? Now, so I'm going to draw my chart. Now, the top line is if only was graphing the amp and period. So I'm going to divide the 2 pi by 4. That's going to be pi, I start with 0 because start at origin on the top, 0. Then go up by pi over 2. Now let's stop here for a minute here. Look up here. I did start with 0. Now I'm going to do my y coordinates. it's important to look at cosine. So would this be 0, 0 or 0, 1 in this case? 0, 1 because I would start at my amp. Because it's cosine. Does that make sense? Okay, everybody look at me. Are we good so far? So I won't start on 0, 0 here because this is a cosine. The original cosine starts at the amp. So that will be 0, 1 there. Okay? So 0, 1. Then go back to 0. Negative 1, 0, 1, 0, negative 1, 0, 1. Now, I'm going to add pi to my x coordinates because phase shift deals with right or left. That's your x. So I'm going to say pi 3 pi over 2 and go from there. Now vertical shift is 2, so I'm going to add 2 to each of my y coordinates. So that's 1 becomes a 3, 2, 1. So this second line is what I'm going to graph on my graph as the transformation of that. Ooh. Just shouldn't look at that. Do I need to go with 1? What's my highest number on that? 3.
The highest is 3 plus 4.
Yeah, so I need to redo my y-axis. So y'all go on and start graphing that. Hello. Okay. It's fine. Yes, ma'am. Yes, ma'am. Sure will. Okay. Are there any questions on that one? I think there's some errors at the end of it. Domain is all real numbers. Your range would be from 1 to what? 3. 1 to 3. Your range is from 1 to 3 in that particular one. Now, guys, I'm going to teach you a new vocabulary word in just a minute. I want you to look up here. This vocabulary word is... Am I good? Something wrong? All right. This word is starting to be used more in math classes, and it's just come out a couple years ago. You see in the sine graph how we went up? Okay, we start at like our home base, go up, back to home base, down to amp, home base, amp, back to home base. I call that line the home base. Okay, the line that runs through those home base points are known as the midline. The midline. It's like the line that runs through the middle of the graph. Like right here. Like this would be our home base. Right here. You set midline. That you're not going to have to know that, but if you ever hear that term, that's the midline. Okay. All right. Let's do one more. Number 4. I'm only giving you one of these tonight to practice. You have 4, 3 of them's like what you've been doing, and 1 is the new type. Okay, that's what you're doing now. All right. Now let's analyze our function. What's our a value here? Negative what? If you want to circle that negative, because do you need to keep that negative in mind? Now, yes, my amp is going to be 1 because the absolute value of negative 1 is 1. But you need to circle, because is that going to affect your table? Yes. You don't need to forget that, okay? My period is 2 pi divided by b. What is my b? 1, so it's 2 pi. Do I have a phase shift? What is it? Pi over 4. What is my vertical shift? Negative 3. Phase shift is opposite what you see, but vertical shift is what you see. Okay?
Does the negative change that?
The negative is going to reflect it, but it's not going to change the amplitude, but in our table it's going to change it, okay?
Is it going to change the shifts?
Yes, it's going to change the...
Right now, the original shifts.
Oh, it's not going to... We're going to take care of that negative in our table, Jack, but it's not going to affect the phase shift, vertical shift. You're going to still move that direction. And I'm going to show you how to take care of that negative in just a minute. We always start at 0. I take my 2 pi and divide by 4. It's pi over 2 again. Like I said, they're going to change. Today they just all happen to be 2 pi as a period. Now, sine, does that start at the origin or at the amp? Origin, so I know it's 0, 0, first of all. But this is where you're going to keep that reflection into. Am I going to go up to positive 1 on the amp, or I'm going down to negative 1 since I'm reflecting? Negative 1. Do you see how that works? So instead of going to 0 then to 1, you're going to go negative 1. That's how you take it. So that's going to be negative 1, 0, 1, 0, negative 1, 0, 1, 0. So after you've done that, you've taken care of the reflection in that situation, okay? Now, what will I do, how will I handle this? Add this to my what coordinates? X. So 0 plus pi over 4 is pi over 4. 1/2. That's going to give me 3 pi over 4. 5 pi over 4. 7 pi over 4, 9 pi over 4, 11 pi over 4, 13 pi over 4, 15 pi over 4, and 17 pi over 4. You said, Mr. I have no idea how you get those numbers. Okay. If you cannot do that in your head, can I see your calculator for a minute? Yes. Zoom in, okay. If you cannot do that in your head, I'm just finding common denominators. So let's just, for example, I'm just going to pick this one and show you how. That's 3 over 2. So in my calculator, I don't put the radian. I just put 3 over 2 plus I'm adding a 4th to it. Change it back to a fraction, and that's what I'm putting down, 7 pi over 4. So that's how I got 7 pi over 4 right there. Like for this one, 2 plus, I'm adding a 4th to it. Change it back to a fraction, math fraction. 9/4. That's how I'm arriving at that value. Does that make sense? So if you can't do that ahead, do it in your calculator. No one's going to judge you. You got me? Do we understand that? Okay. I don't look down on you if you got to use a calculator. What I look for, you get the correct answer. All right, now, what am I going to add this to? The y. So this is going to be -3, -4, -3, -2, -3, -4, -3, -2, -3. And that second line is what I'm going to graph, okay? Derek and Parker, Miss Lynn needs y'all in student services, so you can go and pack up and take your stuff. Do you understand how I came up with those values? I just want to make sure y'all saw the table, okay? So y'all go into student services, Miss Lynn. All right, now I'm going to write my coordinates and make sure you got your homework copy down. Same page as last night, just those numbers. What now? Oh, it does, don't it? Miss Chester made a little mistake. It goes to -4. So I'm going to draw me another one down here, -4. Thank you. All right. See y'all later. So that's going to be -3, -4, -3, See, I like it better on graph paper because you can do the lines. So like I said, I really encourage graph paper. Domain, all real numbers. Range is from -4 to -2. So you can see the reflection was taken care of. The sine graph is going like this. My midline is running through those home base points right there. Is this better than what you thought it was going to be? That's as hard as it gets. We're going to be doing this today, tomorrow, Friday, Monday, and test Tuesday. The hard one's not. Remember, the only time you do table if you got phase shift and vertical shift. Or phase shift and vertical shift on your quiz tomorrow? No, just amplitude and period. That quiz should take you around 15 minutes. It's 6 problems. Then afterwards, we're going to go over that homework and you can do these last 3 examples and then we're just going to practice. If you're going to be out on Friday for the 300 leadership meeting, just watch the video. It won't be a long video. I'm just going to be probably going over homework. But this is what we're practicing. And then on Monday, practice again. Have a checkpoint on this Monday and then test Tuesday.